Sorry, I'm trying not to frustrate Richmond or Mrs. Kendrick. Have you ever had to play Switzerland? I'm trying to be Switzerland right now. Okay. Number 6 and number 30, I think you've had time to grade, yeah? Okay. Let's go down to 56 and 58. Did I give you mostly odds? Yeah. Okay, good, good, good. So then we can know what questions that we have. Oh, pull up the donut holes. There are like 2 or 3 if anybody wants to finish them. I think there might be some coffee too. Not that you were talking about that, but please feel free to finish whatever's over there. Go for it.
I'm like really hungry. Like, Misty, can I go to my locker and get like some food?
Yes, you can go get some food. You're welcome.
Wait, no, I don't want to take it. It's the last one.
No. Kathy, I need people to help me. See, that's perfect, and it's thrown away. You just made my day. And Naomi's, because she would be cleaning it up next period and then be like, what do I do with one donut hole? But you can also go get food, too, as long as you eat the donut hole.
Okay, I will do that.
There you go. Was there any others, or was that it? That was literally it. Okay. Guys, you can check out the questions that are over here on the sideboard. These are the beginning of homework questions, but I know you guys might have other ones to add to it as well. So I'm going to go back to section 11.2. Here we go. And get some pages up. I might not totally go through the solutions because, I mean, if we can do them, that'd be great. But if we can't, I'm also okay with like giving hints and then we continue homework questions tomorrow. I don't mind that also. But I know we have these ones at least. Are there any additional ones that you guys want to add to the list? Besides these ones? No, we're good? Can anybody take any of these ones for participation? We get them on the boards and send them in the group chat? Naomi, which one can you take? Cool. If you want, you can just go erase everything but Reeves' quote if you don't mind. I'll leave it up for a couple more days. Nostalgia. Sally, what can you take? Perfect. What do you think? Can you do the 51 or 55? Why don't you find my book real quick? Yeah, you can erase all that. Actually, Sally, let me move the foci. Foci of my ellipses. Yeah.
It's just asking right or left. Can I just put the explanation?
Yeah. Okay. Yeah. Oh, you did? Okay. And 51's not good?
Yeah, 51.
Okay. Anybody else out there? Hannah or Eric, Daniel, Carrie, Ethan? No? Okay. That's okay. I mean, me doing 2 is a lot better than me doing 4. So if you guys don't mind, let me get this message sent. And then by that point, I think we should be able to check the 2 up at the front. And then we'll go through all together 51 and 55 that were a little bit nasty. But let me grab pictures to them right now so we'll be ready. 51. And then those of you guys that didn't get to look at it yet, you can be playing with it either in the back of your homework spiral, collaborating on it, or... Uh-oh. Oh, even my computer's tired. Oh yeah, the whole thing's frozen. All right, there we go. There's 51. It wasn't even C. Uh-oh, it's a rough one. How bad was it in comparison to what you guys were feeling? It might be. Does that make sense? Like, was it as bad as you thought it would be with it being vectors? Okay, good. Yeah, it's not at all like pre-cal vectors. Riley, did you do vectors in pre-cal? No. And then 55. It's technically like a pre-physics thing, and so some pre-cals do it and some don't. It kind of just depends. Eric and Daniel, had you seen vectors before?
Yeah.
Yeah. Both of you. Okay. Have you guys taken physics before? Okay. That makes a difference too. All right, so we have 51 and 55, so I can play with it. And then, Naomi, let me mark down your participation.
Oh, wait, I can do 55.
Oh, you can?
Yeah.
Oh, okay, cool. Let me put you over here on the sideboard then. Then I'll just take 51, which is nice because he's the longer one anyway. Thank you. Okay, perfect. How are the Santa Barbara signups going today? Are people seeming to want to go? Perfect. Perfect. Okay. I was hoping. Like, I know your class doesn't like everything, and like, but it's a fun trip if you. But it's a fun trip though. Like, if it'd be sad to miss it. That's what I meant. Yeah, I know. But senior day away, like it's the same. It's the same thing. It's not on the calendar yet. There's some weird financial things from prom last year because you guys put on the prom and like the retreat this year because a lot of kids didn't go. Those are usually the class was kind of in the hole coming into the year for a couple of reasons. So we're trying to figure all that out to see even what we have to work with. But we're hoping to do some sort of barbecue, lunch, hangout, yearbook signing, just to have fun. Somewhere around there. It could be like the last school day or it could be the last final day. Yeah. Yeah, it's a safety thing. Because, I mean, technically you get to choose what you do once you get back to campus still, but we just don't want extra driving late at night. Right. Right. And actually that's pretty, I have a few friends that teach at like Valencia and other, it's a pretty common thing with proms to, yeah. But I know it's a bummer. Like, where were we a couple years ago? In Pasadena, there was this really cool Castle Green. It was a really cool venue, and there were like coffee shops all around. I'm like, can I just leave and go to coffee and come back? Like, I would have loved to. I guess it was pretty, but Pasadena's fun too. But anyway, so it's kind of hard sometimes, but it's because we care. They're supposed to be reaching out to you individually, but I would just say, Justin's the one getting the sign-ups. Is he the one that's actually getting them like physically? Do you guys know? What? Barbecue today. Come talk to us, and then we'll get you down. Because we know like there are the academy ones that don't have Bible, and there's supposed to be some way to. I just don't know. Go student council. I didn't think Richmond would be a fan, but I don't know what else to do. Send. Hey. Not helpful. Tap to edit. Send.
What would you like to send?
No, you erased the whole thing?
Send an email or send a text message.
This one. Send this. Do you guys ever have those days that Siri just doesn't work with you? Oh, just kidding. You're not an adult. You guys don't use Siri, do you? Is that just a me thing? And your mom? Everyone says their parents do it. It's so useful sometimes, though. Okay. I apologize. My sound is on only because Mrs. Kendrick, she's going through a lot and I'm trying to help her out. Okay. Is there anything that you guys want to ask really quickly on the ones on the board, or can I start playing with 51? (47 degrees were high, limit was -1. Setting up y. The bottom. Were you supposed to be taking a derivative of 47? Okay. Sally, I'm not sure if you even had to do the DDT then. Like, I agree with your work. I totally agree with your limits, but... Don't worry, just Mrs. Pratt or Mrs. Kendrick. The only thing I would take away, Sally, is you don't have to worry about the derivative. That would be if you were going to, like, velocity or something. But since you're not, you're just worrying about the limit, you're totally okay just to do, like, degrees are tied, -1, bottom wins, 0. That's okay. That's good enough. And it didn't specifically say limit, right, guys? But it was the same idea. And then 37C, it's all about moving to the right with the velocity being positive, and specifically, like you would normally need to look at x prime of t, because moving to the right is specifically a horizontal direction. But Naomi, you said you didn't have to worry about that because there was no vertical? Is that right? Okay, 55. You had your x of t, y of t, first derivative, second derivative. Are we doing acceleration? First derivative, 1 over u times u prime. And then you could do this 2 times this to the -1. So then it'd be -2 times u prime again. Oh, -1.
Yeah.
There you go. Got it. Yeah, that works. Just second derivative. Okay, so then that brings us to 51. 51, we have a whole word problem, and I didn't see any like ABC, so I'm just going to go for it. Is that cool? You guys feel free to chime in as things make sense. Object moving along a curve in the xy plane. There's that wording that we've been seeing. Position vector, they don't give it to us though. Have a position xy, so they're saying it's parametric. We have a dx dt, we have a dy dt is not explicitly given. That's fun. At time t equals 2, the object has a change, yeah? Possibly a net change. Find the x-coordinate of the position at time t equals 4. Guys, what do we always do if we have a derivative and we need an original? Yeah, so can't we do x of 2 plus the integral from 2 to 4? Why am I going from 2 to 4? Time started at 0, but what's the point they gave me? 2. So I had to go from 2 to 4, right? So then x of 2 is my 3 plus, is this a calculator problem? 2 plus sine of t squared. Yeah, this one should have had decimal answers in the back. Did you guys check the back at all for 51? Okay, I love you all, but talking would be really helpful. You can just say no. Don't worry. You know me. My love is not conditional. I mean, I get frustrated, but that doesn't mean that my love stops. Not that I'm perfect in any way, shape, or form. But 51. Whew, decimal. Why am I saying whew? Because who wants to do u sub with t squared with no t in front? Are we tracking? Okay, are we thankful it's a decimal? Yes. Can I just say plus and then you guys figure it out? Is that cool? Okay. But if that was a by hand problem, I'd be feeling it. You guys should be feeling it. All right, letter B, what's going on? At time t equals 2, the value of u. Oh, so they give us like a value, but we still don't know the function for dy dt. Okay, so if the dy dt is -6, right, an equation for the line tangent, well, okay, so what's the form? We always have to start with the form. I'm teaching pre-cal and telling them to start with the form for conic sections. So then, don't I just do a y minus f of a? But in this case, you have to think a little bit carefully. Not just f of a, but y of a. Does that make sense? And be careful, a is a t value, equals x minus... Are we okay so far? Because the a and the f of a doesn't quite work, but the y1 and the yx1 totally do. And then this isn't just f prime of a. What's a better way of putting it? Yeah, y prime of 2 over x prime of 2 because we need dy dx, and dy dx parametric needs both. Is that okay? So all of this was at equals 2, but 2 is not, I need to plug into, and plug into, and then plug into, and plug into. So now I can go ahead and say, well, what do we have so far? Don't we know this guy is 3? We also know y is 5. But then we need y prime over x prime. Oh, we have the x dt. Can't we just plug that in? So we have 2 plus sine of 2 squared is 4. Y prime, what did they just give me at the beginning? Does that make sense? They just say write an equation. So guys, you know better than that. Just stick it to the man. Letter C. Ooh. How much did you guys look at your Endeavor card? Because there was a total distance traveled question. They just said distance traveled that ended up not taking the for each one individually, but instead having to put it all together because the distance traveled is two-dimensional distance. So I can't just take him. I can't just take him. I have to put them together. Has to do with magnitude, kind of a vector. And speed, well, wait, total distance has always been the integral of speed. So the bigger question isn't total distance traveled. Question is speed. Is magnitude. Magnitude is square root of a squared plus b squared. Basically, distance formula. So as we come back here, if I can get to it. Ah, too far. Need to be patient. All we had to do was just plug in square root, right, guys? But what's the dilemma? We have x prime. That's no big deal. What don't we have? Yeah. But am I needing to take another derivative? If I was needing to take a derivative, I'd be in lots of trouble because I can't just use a constant. But if I'm just trying to plug in, I can just go ahead and go for it. So I already have x prime. I already have y prime. I don't need to derive. I can use the values at the point. So can't I just go ahead and plug in sine of 2 squared is 4, and then negative 6? Does that make sense? At the point. It's not an integral over. I'd be in trouble. I couldn't use otherwise. But if you need to, just in case it would help, the formula would literally just be the square root of x prime of 2 squared plus y prime of 2. Does that make sense? Plug and chug and you got it. And last but not least, letter D. All right. You guys see the clue, right? Maybe not what it is, maybe not how to use it, but you see they're giving you a clue, true? For t greater than or equal to 3, the line tangent to the curve has a slope of. You're like, great, that's. Has a slope of. Come on. What do we know about slope of? Which is the same thing in parametric as y prime over x prime is 2t minus 1. Sorry, that I don't know what that is. That's okay. That's it. We'll just for find the acceleration vector. Don't I need x double prime of t and y double prime of t? At 4? Now what's the cool thing that we can do for this guy because we have our calculators? Can't we just do plug and chug such that t equals 4? Right? So that's no big deal. I mean, yeah, you should be able to take that derivative, but it's okay. You can throw in and derive. We only need to go one derivative past what we have. But what's the struggle and why do we need that clue for some reason? I need to take a derivative, and taking a derivative of a constant is not going to cut it. I don't want one value. I need the dy dt. So how on earth is this clue supposed to help? But you know them. They love to be weird. So they're just being weird in a new way. Who's x prime? We have it. Didn't they just tell us what y prime was? Because all we have to do is plug in x prime, move it to the other side. I shouldn't actually cross that out because that would be illegal because I would be having dy dx equals. Anyway, move that to the other side. You have y prime is equal to, and then you can say, okay, sweet. Guess what I'm going to do? Use my calculator? Heck yeah. For what? For that new y prime. Where? T equals 4. God. Is that good? Okay. Was it a little weird? Yeah. But did they give you everything you needed to know? Yeah. All right. So what do we have to remember about AP questions, kids? Almost everything has a purpose. Every now and then there's a little bit of misdirection. That was stinky, because you could have started from 0 instead of starting from 2, and you could have messed things up. Every now and then there's a little bit of misdirection, but they give you clues for a purpose, but you can't always start there. You have to think of what were you given before, and then what comes after. What were you given before, then what comes after. Sorry, Riley, it's always coffee day when I get those unplugged. Kiddos, we have to learn how to graph polar. Yesterday we started polar. Some of you guys wrote down the stuff from the beginning of the year as far as the pre-cal introductory stuff. Did we graph, like when you guys were looking back? I think they got it. Looking back, did we actually graph polar points? We did more parametric than polar, I think, but I think we graphed polar points, didn't we? Okay. So if I was to give you things like, for instance, I don't know, points are one thing, functions are a total other thing. Let's just go ahead and go for a few. So if I was to do, whoa. Whoa, 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 whoa. That does not make any sense. Why does this not make any sense? Yeah, what's a polar point measured by? R equals f of theta. I just put RR. That doesn't make any sense. Lo siento, guys. Haha, that makes sense. R equals f of theta. R is my y equals, R is my function. So first of all, that didn't make any sense whatsoever. Whenever we see a polar point, how do I get rid of that guy? Oh, no, that didn't work. I don't want you anymore. Can I delete you? Well, that's one way. Okay, we'll just do that. Okay. Let's say I was to do 1 and then like pi over 4. Let's say I was to do -2 and like 5 pi over 6. Let's say I was to do like 4 and pi over 2. Wait a minute. Why would you ever be going out of order? That's kind of silly. So let's get the pi over 2 one first. So we'll do 4 and pi over 2, and then we'll do -2 and 5 pi over 6. Then let's do 0 and 7 pi over 6. Let's do -3 and 3 pi over 2. And then let's do something like 4 and 11 pi over 6. Okay, just remind me real quick. How do we do polar graphing? If I have 1 and pi over 4. You would think it's like x and y. The awkward thing is it's really not, because r is really like ry. That's why I had to change that a second ago, but that's okay. Do I do the r first or the pi over 4 first? The pi over 4 first. So we start at the pole. The pole is r equals 0. We turn to 45 degrees, right? Positive. Whenever r is positive, you have a positive relationship with someone, towards them, hopefully. Right? Okay. So that's going to be my point A. What about 4 and pi over 2? Turn pi over 2 and go 1, 2, 3, 4 radii towards. Now hold on, wait a minute. You guys don't have the really cool circular thing. So what are your options? Make really cool circular things or what? Do you need the circular thing? What am I about to do? Gone. Okay, so what do you do instead? Because my page is gone. You say, I know pi over 4. I'm looking at all my points. What's the farthest I have to extend? But the farthest I need to extend is just 4, right? Polar, if you guys noticed, wasn't everything circular? So think a radius of 4. The farthest I'm going to extend is 4. Then all I need to be able to do is go out 4 in any direction. Okay? Now, what angles do you see? I see pi over 4. What else do we see? Pi over 2 and 3 pi over 2. What else do I see? 7 pi over 6. Oh, and 5 pi over 6. Now, whenever I do an angle, I extend it all the way through because remember, you could be going towards said angle or you could be going away, right? So I have 5 pi over 6 or its opposite, which is 11 pi over 6 or negative pi over 6. I have 7 pi over 6 or its opposite, which would be pi over 6. Okay, that's all I need. I don't need all those circles. Cool if you got it, but I don't need them all. So now let's go ahead and let's do that again. If my radius is 1 and I'm at pi over 4, how do I go over 1, up 1? I think about if these ones were connected, where would it intersect the pi over 4? Do you guys remember this? Because the polar thing that you just saw me erase had a circle with a radius of 1, and you would go out that 1, not over 1, not up 1, but out that 1 towards the pi over 4, right? So now what do we do for 4 pi over 2? Well, that's easy because he just is on the axis, so I can name him really fast. I can show him really fast. What do I do with negative 2 5 pi over 6? Negative, so not towards 5 pi over 6. Negative relationship with someone away. So can't I have, right? Think about the 2's and connect the 2's because it's of 2. And so we can go ahead and intersect, and that would be our C. Is this going okay? Now we're at 0 7 pi over 6. Haha, I love zeros. Why? 0, do you go anywhere? Towards or away? Nope, it's just on the pole. But yeah, the origin. Yeah, like the North Pole, South Pole, and this is like the latitudes and longitudes, kind of like that. Here's back. Any special way, shape, what's different from the rest of what we're going to see today. But just reminding you of how points work. So how would negative 3 pi over 2 work? Then go up, yeah, go the opposite direction. And then 4 and 11 pi over 6. Down, but only because you're positively headed toward. It shouldn't be crosshaired because when you twist, it's not the over and up. Does that make sense? Yeah. Important to know because a lot of people would think it's the over and up, and that's why I'm purposely drawing my rotation. And ironically, there actually is like polar graph paper, but okay, those are just points. But the problem is, guys, we're not stopping at points. We're actually going to functions. So in Algebra 1, you first started graphing points, and then you started graphing functions, and that's what we have to do. Now, there technically is something coming where you could, by memorizing ones, you can make an endeavor card of the most common polar curves and what their equations look like, and when A is less than B or B is less than A, or you could do that. What do you think I'd rather you do? Just use tables and use tricks to get them every single time and not need to memorize all of that. Could that be helpful at times? Yes. Is it necessary? I don't think so, but that's for my brain. Or that would be for my brain if I was in your spot. So we're going to have to see how your brain thinks. Let's go and get down to some important stuff. Wait, do you need to write down an endeavor card for slope of polar curves? Wait, did we make one earlier? We did a first derivative because it was y prime over x prime again, just y prime of theta over x prime of theta. I'm not sure if we did a second derivative, but what do you guys notice as far as the second derivative? Yeah. Can you staple the first part on top, if you don't mind? How similar is this to parametric? Very similar. Because don't you still have an x and a y and a, ooh, instead of a v, it's an r? Okay, cool. Don't you still have a theta? Don't you still have trig? Yep. Don't you still have a derivative with y prime over x prime? Yep. Just theta now. Don't you have a second derivative of a derivative of the first derivative over x prime again? Same, same, same. Okay, so I'm basically just reminding you guys of the calculus you already know. Now, there was a whole Endeavor card with vectors and speed and total distance traveled and all that jazz. If we need one, we'll get one. Okay, do you guys know how we had to play around with our graphing calculator in the window and all that jazz? And we had t-mins and t-maxes and things that could go wrong if our t-steps were too big. Guess what? It's going to be super similar, except now instead of t's, what do we have? Thetas. So we're going to have theta mins. We're going to have theta maxes. I'm not going to make you guys like totally go super crazy with all this stuff as far as like playing and making the mistakes and seeing like in polar especially, you can get some great wonky graphs, like way better than the parametric all messed up. We can have fun with that. But the point isn't to make them wrong. It's to make them right. So we won't do that today either. But the idea is you guys should be in radians all the time unless we need to visualize things like tracing, then we'll go to degrees because then we can visualize better. But if you're in radians, in essence, we'll pretty much usually just start with 0 to 2 pi with some sort of theta step that's small. Remember, baby steps get us the whole picture. If it's too big of steps, like your mom checking in on you but doesn't really know where you are, like that gets really messy. So 0.5 should be good, or like 0.1 should be even better. That's just in general for the window without making you guys like make tons of mistakes. But there are some weird things that we saw in parametric that we're going to see here too. Do you guys remember I gave you a trig function with a weird argument and it messed up your window? Do you remember? If we were to do something like this and say, okay, hold on, sine usually repeats in 2 pi and we set this equal to 2 pi, don't we get that 6 theta will equal 2 pi at pi over 3? It's only going to take 0 to pi over 3 for that sine to do one full cycle. So if you were to do your normal 0 to 2 pi, how many cycles would it go through? A lot. So, and if you have your little circle with a little tail, you guys know what I'm talking about from the parametric ones, it's going to like go around and around and around and around. And why is that important? Because you guys see what's on the backboard? Section 11.3, yes, we're reviewing polar. Yes, we're learning how to put them in our calculator. Yes, we're trying to get the hard part. We're working towards what? Area. And areas need integrals, and integrals need bounds, and bounds need a beginning and an end. And if you just always put 0 and 2 pi and it only took pi over 3 to, it's wrong. So we're going to have bounds as well, and that's what makes it a little bit more important as learning how your calculator works, and not just how it works, but how long it takes to do one cycle. Or what if they say, we don't want the entire 12-leafed rose? It's not a rose. I know, they just call them roses. It's a flower. 12-leafed, yeah, because there's 6, and then any even one has twice as many petals. There are tricks. But what if they say, find me the area of 1 petal? Oh, 1 petal. I need to cut my bounds down even more. Or maybe I can go from 0 to here, and then I can like cut it in 12. Or maybe there are different ways of doing it. Or maybe they're like, just get me the area of the inner loop, or just give me the area between the outer and the inner, or just get, So that's all coming. That's all what we're building up to. But in order to build up to the area, we just have to have the basics down. Like, what does it take to graph this, the whole thing, all 12 leaves? What does it take to graph this, the whole thing? Is there symmetry? How do we do it? So anyway, we'll talk about graphing calculators more tomorrow. If you don't have it today, please bring it tomorrow, okay? But then example 2 says something as easy as, yeah, find the slope of the rose curve. You're like, I don't even know what a rose is. Well, it's that thing. R equals 2 sine 3 theta at the point where theta equals pi over 6, and use it to find the equation of the tangent line. Pause. Do I even need a picture? Is there any point to having a picture? No. because all we're doing is slope, equation of the tangent line. Yeah. Can't I just do y prime of theta all over x prime of theta such that theta is equal to pi over 6? But does anyone see a problem? Slope of the tangent line, dy dx, y prime over x prime, no big deal. Let's go. Pause. Parametric, you get x's, you get y's. Polar, who don't we have? Come on. I know we have brains. Come on. We need to do this. Who don't we have? We have a theta. I agree with Hannah. We don't have a point. Can you expound on that? What don't we have? We don't have an x or y. How can we do x prime, y prime? How can we do x of or y of? We don't have an x or a y. Why not? Why am I going to get a highlighter and make it thick? Say, ooh. You're going to have to make your x. And you're going to have to make your y in order to use them. Parametric, they say, oh, x of t, y of t. Here you go. Polar, they say, we don't do x's and y's, we do r's. And you're like, great, I have to make my own x's and y's? Yeah. So then, now that's technically in your forever card somewhere. It's basically parametric. Instead of v cosine t, or v cosine theta and v sine theta, it's r. But otherwise, it's the same idea. So the struggle is, well, wait a minute, hold on. I have to make my x of first. Oh, I know. Oh. So x is equal to, and y is equal to. You guys see what I'm doing? And wouldn't we need that? Because we need to go ahead and do. So is the formula hard? No, the formula is not hard. But what is hard? Making it. Yeah, because now it's like, didn't look that bad when it was just the r. But now if you're allowed to use your calculator, you guys remember in parametric how that little second base had like x prime? Polar does too. But do you see what I see? I don't think this is a calculator problem because that's unit circle. You know what I mean? So then what are we going to have to do? For this, no big deal, plug in, know your unit circle. For this, no big deal, plug in, know your unit circle. For this, what? It's just going to take time. Does that make sense? So it's not awful, it's just going to take time. But do you see what? We don't even always have x's and y's, so we have to make them. And number 3, the best are going to be a mess until we get more familiar. Does that make sense? So what we're working on tomorrow. Like with parametric, reading questions and being like, what are the wordings, what are the words saying? How do they apply? How do I use calculus? All while trying to get more familiar with polar curves. Okay? In homework, because we have another, minute? And then I get to go try to play. What's it called when you're trying to stop things from exploding? Let's see. Looking at section 11.3, I just want to see what we can. Oh, look, polar curves. Yay. Oh. Ooh. Anyway, there's fun stuff coming, but we're not there yet. Guys, homework starts with pre-cal. Is that nice? Hopefully. So you can go ahead and look, you're just plotting polar points. Please don't do all the concentric circles. Just do what we did today in class as far as plotting what you need. These ones, you have x's and y's. You're getting r's and thetas. These ones, you're trying to convert equations. This entire page. You have to go back to the beginning. Does that make sense? Play around with the pre-cal. Come tomorrow with, you know what, I'm not so hot at doing this. Is that cool? Okay. There's a good picture here too, Riley. You want to take it from there? I don't know if that'd be easier. All right. Play around with homework. Play around with the pre-cal. Play around with getting used to polar. And then tomorrow we can go into the calculus, but